Now that we've added a bit of detail to our sheet metal example, the next thing we really need to talk about is adding the holes to the other solid body. And because we're designing parametric parts, we want to make sure that we use references whenever possible. So that means that we want to make sure that the holes we add in the top piece are going to exactly line up with the holes we've already created. And there are several different ways that you can approach that, but let's take a look at what we have available to us now. So inside of this edge flange, when the hole is created, if we expand this feature, we have two sketches. Sketch 15 is the one that I created inside of the hole wizard feature. Sketch 18 is the sketch that was created in order to make our revolve cut. So what we want to do in this case is show sketch 15, and now we have a perfect reference for where the center of that hole needs to be. Let's go ahead and start a sketch on the top face. And in this case, we're going to do a simple hole. So I'm going to do a circle that snaps to the center. And in this case, I'm going to give it a 0.3 diameter. Now, as we look over here, we don't have a reference sketch for the mirror. If we expand the mirror, it just shows we have a mirror of the bend. It doesn't show that we really have a mirror of these sketches. So what we really need to do is we need to figure out if we want to create the hole here and then do a mirror feature, or if we want to make some sort of relationship with this, assuming that there's no sketch entity here. So I'm going to go ahead and show you how to make the relation if you don't have a sketch entity to use. The first thing I want to do is go back up into the top of my tree, and the body that we're actually dealing with here, fillet 2, I'm going to hide it. And the reason I want to hide it is because it gives me easier access to this information. So I'm going to start a new circle, and the first thing I want to do is hover the mouse over one of these circular edges. Now you'll notice that when I do this, it gives me a center point. Now, once the center point is shown, I can simply navigate over to it and I can place the center of my circle there. Now, as we select this circle and try to move it around, it says it cannot drag it because it's fixed in place. It has a coincident relationship with the center of one of those circular edges. Then I want to select this circle, and make them equal. So that way their hole size doesn't change. Now we can say OK, we can re-show that solid body, and we can do an extrude cut. One nice thing that extrude cut has that we don't have when we're doing something like a hole wizard hole is the available option to link to thickness. This goes directly to the thickness value that's inside of a sheet metal part. It places this in a custom property in all sheet metal files. And I'll show you that in just a second. But I want to make sure that I select both contours. I want to select this hole and this hole. We also are going to allow it to auto-select the bodies because it's only going to go through the first body since we sketched on the outside face, and say OK. Now we can go back and we can hide sketch 15 and collapse that feature in the tree. So you notice we added those holes. And at this point, if we modify any of the original parameters for our sheet metal part, we know that everything would float around with it. But let's add a few more holes. So now we want to add holes to the side face. Again, we're going to sketch. And now that we know that we don't have to worry about the sketch references, that we can use the physical references of that hole, let's go back and let's hide the original body, in this case, cut extrude 1. And let's place some circles here. Now, I'm not going to dimension anything just yet. What I want to actually do is go back into my feature tree, expand cut extrude 1, and I want to show this sketch. I'm going to see if it'll allow me to relate it back to the original hole that I added that dimension to. Now, you'll notice that there's no option here to place an equal relation. Now, in the past, Solidworks would actually let you apply some relations across sketches. But now you have to include them in sketches, or you need to use some of the other options that Solidworks allows. So if I wanted to relate this value to another value inside of my design, I would either need to create a linked dimension, or I would need to create some general global variable inside of my equation manager. To show you that, let's go ahead and create a linked dimension. Back inside sketch 21, I'm going to edit this sketch. I'm going to right click on this number. I'm going to navigate down to link value, and I'm going to call this PEM through hole and say OK. Now you'll notice when I do, I get a little red chain link icon next to it. I can then hop out of that sketch, go back into sketch 22, right click on this dimension, and link the value. I get the same dialog box, but now I have a drop down, and I'm allowed to select PEM through hole, say OK, and now these values are both linked. Now the way a linked variable works is if I modify any one of the linked values, all of them are going to change. So this allows me a quick way that I can modify all the holes at the same time without having to go back through all the sketches. We can also access that through the tools in the equation manager. You notice this shows all of the dimensions that are in my feature tree. It also shows us things like the thickness of the sheet metal. It also shows you the global variables that are currently linked, such as the thickness of the sheet metal and the PEM through hole. Now, if I scroll all the way down, I can find the PEM hole and I can find exactly where I placed it, and I can modify this. Let's say it needed to be 0.3125, say OK. It's modified not only sketch 21, but also sketch 22. So this is a quick way that we can handle this type of functionality. Let's go ahead and show cut extrude 1, go back down in our tree, select sketch 22, let's do an extrude cut. Now in this instance, I'm not going to link it to the thickness because I want to go all the way through. Since this is a through hole, I don't have to worry about mirroring the feature. I can either say through all, or I can say up to surface, select the outside face of my part. But in this case, I need to be very careful. I can't use the auto option for selecting bodies. I need to manually select the bodies I want to cut away from. Now in this case, I only want to cut away from the external body because the internal holes for the PEM inserts are smaller. So you notice now we've created a hole through the outside of our part. We can go ahead and fit to screen, and we can save this. Let's go ahead and do a save as. Make sure that you put a number 3 after it. And I want to take a look at a little bit of parametric design, how things can be updated. The first thing I want to do is I want to make sure that all of my sketches are hidden. And then I want to take a look at modifying this design. Let's go up to Tools, down to Equations, and let's take a look at the Equation Manager. I'm going to try to minimize this as much as possible so we can still see the design in the background. Try to move it over to the left and minimize the tree. So as we're looking at the Equation Manager, every dimension that we've created inside of this file is located in here. For instance, D1 at sketch 1 and D1 at sketch 2, these were the original dimensions that created the base size of our box that we used to convert to sheet metal. So let's take a look at modifying these values. For instance, D1 at boss extrude 1 is the overall height of the box. Let's say that we wanted this to be 6 inches. Let's rebuild that. You can see that the box gets taller. And because we've used good parametric relations between everything, you notice that the box not only updates, but also all the tabs update as well. Let's take a look at modifying the overall length of the box. Instead of 8 inches, let's say that we wanted it to be 12 inches. Rebuild the file. You notice the tabs move out based on the dimensions we gave when we were creating those flanges. Now, of course, we could go back and move the flanges or add more, depending on what size you want the actual box to be. Let's take it back down to 8 inches and rebuild the file. So you'll notice that everything has a nice way of updating. All the tabs update, all the holes update, all the locations of our components update. This is exactly what you want to see when you're dealing with a parametric file. You want to make sure that the relations that you create between sketches, between solid bodies, between features, are all strong enough to update whenever you change your designs. It's going to save you a lot of time going down the road because you don't have to redesign everything. You can simply manipulate the values and update them. Now, let's determine what this enclosure is actually going to be used for. Obviously, we might want some mounting holes in the bottom. We might want some vents in the side. There are different ways that we can approach that sort of functionality. Let's start by hiding the top, and let's start a sketch on the bottom face. Now, let's say that we wanted to place a few different hole patterns in here. Let's say that it was going to be 1 by 1. Let's say we had 1 by 2 over here. We can place these rectangles, we can convert them to construction, and we can use their corners for locations of holes. Now this is a good way to do it because we have nice strong references, we have solid geometry here that we know we can move around and modify. But we do want to make sure that everything's fully defined. We're going to make sure that this specific box is 2 inches over and 1 inch above. And then we want to make sure that this one is 0.75 below the origin and 1.5 away. Now we're going to place some circles in all 4 corners of both boxes. Now we are adding a lot of additional sketch entities in here, but it is a good strong way to make sure that we have fully defined sketches. And then I'm going to go back and make sure that all 4 of the holes on each of these are equal, and then I only have to dimension 1 of them. And I can take this on my feature tab to a cut extrude, link to thickness, and I've created the holes in the bottom of my part. Let's say we want to add some venting to the side. Now, inside of our sheet metal section, we do have a vent feature. Now, a vent feature allows us to use things like sketch elements to help determine whether or not an area is going to be populated for a vent. Let's take a look at a simple example. I'm going to start by drawing a few circles directly in the center. So we have one that is 3 inches, one that's 1.75, one that's 1 inch, and we're going to go ahead and make this one 2.25. Now from here, I'm going to draw some lines. And these lines are going to go from the origin of the circle, straight up, straight over, straight down, and straight out to the left. The next thing I want to do is I'm going to make sure that this is actually located a certain distance away from the origin. I want to make it 3 inches up, and then I want to make sure that it's actually vertical with the origin. So I'm going to select the center point, select the origin, and make them vertical. So now it's fully defined. So with this sketch, I'm going to go into my vent tool, and I have a few selections to make. The initial boundary is automatically created based on your selection. It takes the largest section of your sketch. Now this doesn't have to be a circle, but this is probably the quickest way to example it. Now as we scroll down, you'll notice that we have some cool options. We can automatically add fillets in the corners. Go ahead and add a 0.02 fillet, but you'll notice that there's nothing really to add a fillet to yet. We can make some more selections. Now as we go down, it also shows you the flow area. We can select ribs and spars. So let's select some ribs. So you notice by selecting the 4 straight lines in our design, we're able to create 4 ribs inside of this opening for a fan. When we select spars, we can select these circles and create some additional structure in here. So again, it's a very quick way for us to make this sort of fan opening fan profile. Now each one of these has various properties that you can modify. For instance, we can make the original ribs thinner, and it also shows you the open area. Now we have 73.47% open area. If we take them back up to 0.2, it drops to 68%. This helps you when you're trying to calculate things like the amount of flow that you're going to get from your fan. When we take a look at the spars, we also have the amount that we can enter here. We can bump them up to 0.1, make them a little bit thicker, make sure that we have enough structure here. We have a fill-in boundary section as well. If there are areas that you want to add in for support, you can select those areas. Now, of course, this is one single sketch, so what it does is it actually creates a solid body. But you can go back and you can manually select certain sections that will allow you to fill in certain areas of your vent. As you scroll down, there are some favorite options. You can save all your parameters in here. But for now, we just want to make sure that we understand that this is a very quick way that you can make vent profiles in here, because it takes line sketches and offsets them in both directions, as opposed to actually having to draw all this and trim it all out in a sketch. Now this is where the fillet option comes in handy. We can put a fillet everywhere there's a corner intersection. And that's something that you're going to want because you don't want to have to go back and manually fillet all these. It's very nice because it updates parametrically. Say OK, and the vent feature is created, and it goes directly through one face of the sheet metal part. Because it's done in a sheet metal feature, it uses the thickness option, and that way you don't cut out from additional information. Let's say we needed that vent on the other side. We can go into our feature tab, we can mirror, select our mirror plane, and we can mirror that directly across. So again, this is a great way to add a lot of detail very quickly and easily in our sheet metal part. Let's go ahead and turn our cut extrude to our top part back on. Let's save this. That's a great place to stop.